Super, thank you. Hi, everybody. So I'm going to talk to you about a new data publication workflow called Publish First. It's based on GPT-4 and it's aimed at smaller institutes with minimal resources. Clicker doesn't work. There we go. So these small institutes often have unique contributions to global biodiversity data in their collections, but their collections are often physical only, in other words, undigitized and unpublished. This means that they're vulnerable to things like accidents, fire and flood and so on, and also physical wear and tear from handling. Obviously, there are lots of good reasons to publish your data, but this is just one that I wanted to highlight particularly. So small institutions often face specific data publication challenges. We came up with this workflow when we were in Tajikistan doing a GBIF-funded CESP mentoring project to help herbaria there get their specimens digitized and published. Small herbaria in Tajikistan, and I'm sure small institutions all over the world, often don't have many members of staff, which means they don't have technical specialists on hand quite often. In Tajikistan and other non-English speaking countries, these small institutes are often in rural areas where you might not have employees who have good English skills. And it's worth noting that most of our how to publish guides and how to clean data guides are in English. Few members of staff means that they don't have much time for digitization, and smaller institutes often don't have the resources for buying equipment like expensive scanners and so on. In Tajikistan, the laptops they were using were quite old quite often, so it was difficult to install software on them, and internet access was also intermittent. So we encountered this quite specific range of problems or challenges in Tajikistan, and we decided that we needed to drastically simplify our usual publication process. So we did that, and we tried to design our workflow so that it doesn't require any specialized software. It should work with intermittent internet. And we also used low-cost hardware. We used these €300 document scanners. And sure, they don't give the same results that a professional camera setup does, but they do give good enough results to be able to do quite a lot of fine detailed analysis and work. So the workflow from the user's perspective looks like this. They take their laptop, they plug and play their document scanner, they plug their scanner in, they get some specimens and stick identification labels on their specimens. They scan those specimens, and the scanned images sit on their laptop where they get synchronized with an S3 bucket we have set up. So you can think of an S3 bucket as being kind of a glorified Dropbox. From the user's perspective, this is all that they have to do. Obviously, it's a bit more complicated behind the scenes. So we have an image which gets uploaded, and we have a Python script which here's that upload event. It sends the image to Google Vision API. From Google Vision API, we get back some text, all of the text that's basically on the label, which looks like that. We send it to GPT-4 with a prompt asking it to give us Darwin core terms back. These Darwin core terms get appended to a text file. And that text file is set up in an IPT as a source, as the source for a data set. The IPT is automatically publishing that. So this is an automated kind of hands-off approach to the data publication from the back end. One question we were quite interested in is whether GPT-4 is good enough at extracting Darwin core terms from label text. So we took a data set which had already been transcribed by humans, and we compared what the humans had put in the Darwin core terms to what GPT thought the text should be in the Darwin core term. So for the picture on the right, you can see that, oh, on the left, sorry, you can see that GPT-4 gets the same, exactly the same Darwin core term string as the human transcriber about half of the time. So when it gets a different string to the human transcriber, it's sometimes, fairly often, I would say, actually better or more extensive anyway. I'm zooming into the example which is on the image. You can see that at the top there is some text about the locality description. The next column along has the human transcriber's text in the locality, and you can see it's shorter than the last column, which is GPT-4's text that it has put into the locality Darwin core term. So it should probably be verbatim locality because there is non-locality information in there, but you can see that GPT-4 has captured more text than the human transcriber. In terms of cost, GPT-4 for around 100 specimens is costing around $2.20. We've found that GPT 3.5 is a lot cheaper, but it does hallucinate, whereas we don't get any hallucinations so far anyway that we've seen with GPT-4. The picture on the left is of a Tajik dataset from one of their herbaria, which was published using this method. We also plan to kickstart the digitization process for some Norwegian datasets using this process. We have another mentoring project in Uzbekistan where we plan to use it, and there's also been interest in Armenia and Italy. So there are, in terms of what's next, there are definitely technical improvements we can make. We can also look at other large language models to try and bring the cost down a little bit and see how good they are. And we should probably think about integrating some data correction and cleaning services into this workflow. The other thing I've been thinking about is we've got this workflow for images, and it's meeting several criteria. It's working well for people who don't have any technical knowledge, who don't really speak English. And it's quite fast and quick and easy. It's not taking much time or effort, and it's semi-automated. We've got this workflow for images. It would be cool to think about one for spreadsheets as well. So spreadsheets are a little bit more tricky. As anyone who's ever received a spreadsheet from a biologist knows, they can be somewhat cryptic. So when biologists send me spreadsheets, I tend to have quite a lot of questions and dialogue asking them, what does this column mean, and so on. So I was thinking that an interface for semi-automatically publishing spreadsheets, a good interface might be a chatbot where you have the potential for dialogue. So I built a prototype chatbot, which you see here. The user uploads a spreadsheet, and the bot, which is based on GPT-4, works through a series of tasks. It tries to do as much as it can on its own, but when it's not certain about something or it needs confirmation from the user, it engages in dialogue and asks the user questions. Once it decides that it needs to do something to the spreadsheet, it writes Python code and executes the Python code on the server. So the user doesn't have to have any technical knowledge. In fact, they don't even need to know what data standards are or what this process is actually involving. the bot is kind of leading them through all of this, and it's doing all of the technical work for them. Once the human and the bot are happy with the state of the spreadsheet and think it's ready for publication, the bot has access to a publish to GBIF function, and it can use that to publish the data set automatically. So we're basically talking about a chat interface for the IPT. What you see here is in English, but GPT-4 is just as good. If this was a Tajik researcher, for example, they could be speaking to the bot in Russian, which I think is a big win. So the takeaways I would like you to have from my talk is that this publish first workflow does alleviate, and we found it works quite well with smaller herbaria in Tajikistan. Yes, it's quite scary to publish data without a human vetting it, but we have to be pragmatic and practical. It's better to get the images and some data published than nothing at all, I believe. Finally, we're at a really exciting point in time now where the capabilities of AI and large language models are absolutely skyrocketing. I think we're at a unique time where we can think creatively about new user interfaces for things like data publication, data cleaning, and even things like data usage. So yeah, it's an exciting time.
And we do have time for one or two questions. Any questions in the room?
Thank you for such interesting talk. Just a question. Was it too difficult to correct the data by humans? So it's a small herbarium, maybe not so many scans. Maybe it's possible to correct it and then upload to GBIF.
I don't think that we would. I think it's easier and provides better motivation for people if we upload it and then they correct it. Because of course, when you upload something, you can always correct it afterwards. The problem is if we wait for them to look at what GPT-4 has come up with and then we publish it, we would wait quite a while. So I think in our experience, it's better to do it the other way around. Publish first, correct after.
We have time for one more question. Okay. This one first.
Hello, really interesting talk. I'm Victor Shields from Pictura. I was wondering if there's certain limitations for handwritten text or different languages. I think you mentioned that about 50% of the time it was accurate. Was the other 50%, did it deal with some of those instances of handwriting or?
So it's actually been, the Google OCR has actually been surprisingly good at even quite old-fashioned handwritten Cyrillic. We were surprised by that. No, it's 50% of the time, quite often because the human transcriber has edited things slightly, or GPT-4 has just extracted a bit more information. Yeah, so I would say that there hasn't been, that we've encountered any problems with language or handwriting or even different characters with the OCR.
Awesome. We don't have time for any more questions, but please feel free to use the Slack or the last 15 minutes. And our next presenter is Vince Smith. So take it away.
I might use your mic if that's all right.